Yeah, I'm filming.
All right, if everybody could get out their papers, I'd really appreciate that. And we're going to go ahead and get this started. So, the first problem for your homework, and everybody say hi to Calvin.
Hi, Calvin!
Feel better.
All right, now back on me. No, back on me. Okay, perfect. Oh, all right. Okay, so given that 1 kilocalorie of heat is required to increase the temperature of 1 kilogram of water by 1 degree C, all you have to do to find out kilocalories of 100 kilograms of water by 20 degrees C for a bath, you just take 100 kilograms, okay, times 20 degrees C. I don't know how to write that, evidently. 20 degrees C will give us 2,000 kilocalories. So now I'm gonna let's see if I can make this go up higher. And I'll erase this since my smart board isn't so smart. So, so I want to figure out how many joules that is, right? So I've got 2,000 kilocalories. Okay, how many? 1 kilocal, and I love the K because that tells you a kilo is what? 1,000. 1,000. So I got 1,000 calories, okay, in 1 kilocal. So that's going to get rid of this, okay? And if you used your book, you could see that, in fact, the conversion for 1 calorie per joule is 4.816 joules per 1 cal. Okay, so hey, and by the way, if you got this on your own and you're looking at your sheet that I didn't have you turn in, that's your work, great. Okay, and this is the thing that I'm sure, like for some of you, is like super boring. This is for the math dummies like me. Okay, did I call you dummies on camera? Yes. Yeah. All right, I'm sorry. Okay, but I'm with you. All right, so I'm sorry for those of you who are like awesome at math and know all these things. Good for you. Okay, so what's that give me? That gives me 8.37 times 10 to the 6 joules. Okay, any questions on that one? Okay, do you all see what I've done? Okay, the problem I know for some of you is that first one, you didn't know maybe how to get that started. Several people emailed me, and that's fine. I'll help you get started, okay? In fact, it was great. Christiana, not to pick on you, but I just happened to be online, and she asked a question, we just chatted about it. Love to chat. It's so much fun. Okay, so how many BTUs is that, right? How many BTUs is that? All right, and hey, maybe, what if I did this just for a second? I'll mute this on my smart board. Okay, so how many BTUs? So I got 8.37 times 10 to the 6 joules, okay, over 1. And I know that 1 BTU is equal to 1,055 joules. And that gives me 7,934 BTUs. Okay, all right? Everybody got that? The next question says then, if your water heater can now supply 40,000 BTUs, how long will it take to heat this water? Okay? So I got these BTUs. Sir, you always look shocked. You should know it's happening. Okay? I want to know how many BTUs, or how long it's going to take. Now remember I gave you the hint, 7,934 BTUs, and it was 40,000. Okay? She goes, you're trying to help the slow math person?
Yeah, you were like, wait, how?
No, I was trying to think of what I'm going to say next. What is that? 40,000 what? BTUs per hour. BTUs per hour. Okay, per hour. Okay, so that gets rid of the BTUs there, but it gives me something like 0.197 hours. Okay, right? You guys, I really wanted it like in minutes, even though I didn't say it in minutes, because who knows what 0.197 hours is. So if you take that times 60, that'll give you 11.9 minutes, okay? So just you know, it's not that big a deal, okay? It's not that big a deal, but like, you know, there you go. All right, then 2A. I'm going to erase this and we'll look at 2A and then we'll move on.
This video isn't very well produced.
What's that?
This video isn't very well produced.
Shut up. That is horrible. Okay. So, given that 1 kilowatt hour equals 3.6 megajoules, and that 1 BTU equals 1,055 joules, show that 1 kilowatt equals 3,412 BTUs. Okay, pretty easy, because all you have to do is take 1 kilowatt hour. Okay, all right, that's what we're starting off with. Over 1 times 3.6 times 10 to the 6 joules over 1 kilowatt, okay, hour. So that's going to get rid of that, and we're going to multiply that. Let's get rid of let's turn joules into BTUs. British thermal unit BTU over 1055 joules. And that gives me 3,412 BTUs. Okay? And the answer, the extra credit answer was, of course, you cannot, you can't actually say that 1 kilowatt hour equals 3,912 BTUs, because what's going to be lost?
Conversion factor.
Yeah, the conversion factor, the heat, okay? Now I want you to turn onto page, everybody turn on to page, Well, turn on to page 50 real quick. Keep filming
I was
this.
gonna say,
Okay,
am I
thanks.
still filming?
Turn on to page 51 real quick, and on the free response question, it's talking about uranium-235. It talks about its atomic number, okay, also talks about its half-life, and then it says that assume that a nuclear power plant can convert energy from uranium-235 into electricity with an efficiency of 35%. The electrical transmission lines operate at 90% efficiency, and fluorescent lights operate at 22% efficiency. I want you to flip back now to page 40. On page 40, you can see something very similar. You've got coal to electricity, transport of electricity, light bulb efficiency, and that gives you all the overall efficiency. So if you're doing problems like this, and I guarantee it's going to be on the AP exam, all right? If you're doing problems like this, you just convert the percents to decimals. So in this case, it was 35%, but it's 0.35, okay? Times, and it's 90% efficient, so it'd be 0.90, okay? And its light bulb efficiency is 5%, so that's 0.05. Okay, and what's that going to give you? That's going to give you 0.016 or 1.6% efficient. Okay, so anytime you have that efficiency, it sounds like ridiculous, but all you have to do is multiply each of the percents that you've converted into decimals to get the whole thing. Okay, has everybody got that? Okay, that's pretty easy. And let's keep reminding ourselves of like these. What's going on there?
Just getting my desk pushed forward.
Don't push your desk.
I was
I'll push
kind
your desk.
So now you're a tattletale.
apparently.
I didn't know where to go with that. All right, now let's remind ourselves, because even like this morning I was talking to somebody about that whole rate change thing, okay? Like this percent efficiency thing, this is going to just keep popping up, okay? That's why it's early on. I mean, this is not about an energy chapter, okay? Even though energy stuff is in here. So let's not forget that, and also let's not forget, like if I had a chart like this, boop, 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 you know, and I say, what's the rate change between these two things? Is it past minus present over present, or present minus past over past? That one, yeah, that's what it is, okay? You take the present, okay, or most current date, divided by the past over the past to give you that rate change. Or there was a weird way that Keegan was doing it, and don't do it that way. Okay? Any questions about this math stuff from this chapter? Okay, because they're going to ask you these questions, very similar questions, on your homework. Brady. Oh, you had this like, it looked like you were like trying to ask a